and gentlemen, this is Changes in Matter and correlates with Chapter 3.4 in your textbook. Your key concepts for this video are: compare what happens to a substance in a physical change and a chemical change, and how are changes in energy and matter related. So let's first talk about changes to matter. One type of change is called a physical change. This is where you change the form or the look of the matter, but you're not changing the chemical structure. So the end products have the same properties as the original. Think about chopping a piece of wood in half, crumpling up paper, melting water or ice cubes, blowing up a balloon. All of these are changing how the matter looks, but they're not changing the chemical structure of that matter. Now, in contrast, we also have chemical changes. Now, chemical changes do change the chemical structure. You end up with something completely new. It has new properties that are completely different than the original. So think about pancakes. Raw pancake batter is completely different than a cooked pancake. It tastes different, it looks different, it smells different. All of these are different. Or like rusted nails. They have different properties than fresh nails. Ripened fruit versus unripe fruit. A burned match versus an unburned match. Generally, a helpful way to remember a chemical change is if you can't undo it easily. Now, that's not foolproof, but it is very helpful. Now, we've actually got a couple signs to help us remember that a chemical change has happened. There are 5. One of them is that there's a color change. When you mix it together, the color has become something new. Think about the raw pancakes versus cooked pancakes. Temperature change. It got hotter or colder. A gas is formed. Carbon dioxide bubbles are released or things are burning. That's because there's a gas there. An odor change. Raw eggs versus cooked eggs, they smell very different. Or a precipitate is formed. This is basically a solid. See these two clear liquids? When you mixed it together, it got all cloudy. That's because a solid was formed in it. Now, whenever we have these changes, physical or chemical changes, our law of conservation of mass says that matter cannot be created or destroyed. It can be transformed into new things, but you're not destroying it, or you're not creating it. You're transforming it from raw ingredients into something new. Now, changes in matter and energy. All matter has energy. So chemical and physical changes, those changes involve a change in energy as well. So when this ice cream melts, not only are we changing it from a solid to a liquid, but we're also increasing the amount of energy in that ice cream, which is what's causing it to melt. Or burning wood. It's a chemical change. That wood is completely different once it becomes ash, but there's an energy change happening which is causing this. Now, there are 2 types of main energy changes. We talked about a sign of a chemical reaction. If it cools down, that's called an endothermic reaction. This is a change where energy is absorbed into the matter, which makes the surrounding area feel colder. This is things like those instant ice packs. When you pop them and shake them up, they get really cold. That's because an endothermic reaction is happening. Those molecules are absorbing all that energy. For example, ice melting. Ice is absorbing the energy around it, which is causing it to melt. In contrast, we have an exothermic reaction. This is where energy is released out. This makes the outside air feel warmer surrounding it. So think about those hot hand warmers that you use in the winter. When they get exposed to the air, an exothermic reaction happens, and it makes your hands feel all nice and warm because it's releasing that energy. Another example beyond the hand warmers is also fireworks. It creates a very sudden, fast, boom, exothermic reaction, which is what causes that explosion. That's it. Be sure your notes hit all the key concepts and vocabulary, and if you wish to, feel free to try this challenge question.